Hello, everyone. I hope you're having a great time here at the Dev Days Conference 2022. Welcome to the next session. I'm sure it will be very interesting for you. So lay yourself down and make yourself comfortable. At the end of the session, there will be time for a Q&A. You can post your questions in the Q&A section whenever you want, and our speaker will kindly answer them. Keep in mind also that our Knowledge Partner Pact will be giving away 20 ebooks to the most active conference attendees. So we urge you to participate and be active. Rate sessions, leave comments, ask questions, and you can win a great ebook from our Partner Pact. Okay, now let me introduce our speaker, Arne Lapõnin. Arne works as a consultant developer at ThoughtWorks Spain. He's fascinated by using data to create tools so that people would be empowered to make better decisions. Over the last couple of years, he has been helping clients with data engineering and data platform projects. Arne loves climbing and skateboarding, and he's also obsessed with the good coffee like me. The topic of his talk will be what can go wrong with testing in an ETL pipeline. And this talk will be about how a testing strategy evolved in one of the analytics project Arne was involved in, and how we learned these old lessons the hard way. Arne, it's your turn. Over to you. Excuse me, Arne, we cannot hear you. There is some problem with the sound. No, we can't hear.
Okay, can you hear me now?
Yes, yes.
Oh, okay.
Now it's okay.
I'm sorry for this confusion.
Don't worry about that.
Let me share again. Okay. Okay. I started sharing my screen and I'll start from scratch. We have plenty of time. So, as Emil said in his introduction, my name is Arne Lapõnin, and I'll present you the topic of what can go wrong with testing an ETL pipeline. So the goal of my talk is, first of all, to talk about testing ETL pipelines, but also, and this is a much bigger goal, of reminding that even though we are now in the domain of data and data engineering and also machine learning engineering, the good old practices that we have learned over the last 30, 40, 50 years of creating software projects, they still apply to these new domains as well. And they will be applicable in the next many years to come as well. So yeah, that's the goal of this talk. And in this talk, I'll cover a couple of things. So I'll first introduce what do I actually mean by a data pipeline. I'll try to give an introduction to the project that I'll use to illustrate some of my ideas. Then I'll go through the various phases of testing that we applied in this project. And in the end, I will wrap it all up and talk about some of the lessons that we've learned. And yeah, this talk will be a bit shorter, so there will be quite a lot of time for Q&A at the end as well. So feel free to ask me any questions later on. So first of all, why do I actually care about testing? And this is where I want to talk a bit about my personal life. So I live in Barcelona, and it seems that everybody here is absolutely obsessed with climbing. And so am I. Like, it's an absolutely fantastic sport, and like I'm a huge adrenaline junkie due to that. And when you do climbing, one of the things that you really need to make sure is that you're safe. Like, safety always comes first. So at the beginning of each climb, you have to do a safety check with your partner to make sure that your equipment is top notch and that everything has been essentially configured okay. Like, you need to make sure that you'll be safe when you climb. And that kind of helps me think about the systems that we create as well. So if we deem something to be important enough for us to build and for us to give to our users, we also need to make sure that we actually know how it works. And testing is one of the easiest ways to make sure that we understand the systems that we build. So what is a data pipeline? Essentially, a data pipeline is a system, and in this case, I'll bring an example of an ETL pipeline, which takes some information from data sources. Uh, the data source can be a database, an AWS S3 bucket, or even a file system. We extract data from the data source. We apply some sort of transformations on it because usually we don't want to deal with raw data. We want there to be something on top of this raw data. So we apply some transformations and then we load the data into another destination, basically. And that destination can also be a database, a data warehouse, a data lake, or even a delta lake. And yeah, this process, like the extraction, transformation, and loading, this can be the essence of a data pipeline. There are other ways of constructing pipelines as well. So there's an ETL pipeline, there's an ELT pipeline, but in the context of this talk, it doesn't really matter. So how do we actually start testing data pipelines? So intuitively, you might think about a data pipeline. You might start thinking about a data pipeline as though it was a black box. So you have some data coming in and you have some data coming out. And if you treat it as a black box, you don't actually care what's happening inside. You just care about like the outer rims of the system. So what's coming in and what's going out. The reality is actually a little bit more nuanced. So I like to think about testing a data pipeline like about this domain in like 3 separate subdomains. So first of all, does the data pipeline actually produce anything? In this case, we can talk about testing the infrastructure. So is anything actually being produced from the pipeline? The second area is how good or bad is the extracted data. So what's the actual data coming into the system? And in this case, we can talk about data quality of the data coming in from our source teams or systems, and whether it actually matches the kind of data that we expect to deal with in our system. So in this case, we can talk about data contracts, which is a fancy name for basically doing schema validation. So for example, that like a customer ID is actually an integer or a string, and we know how to deal with those data types. The third area is how good or bad is the transformed data. So what do we actually do with our data inside of that black box of the pipeline? And then finally, we can talk about like, are there any problems running the pipeline? So monitoring, for example, goes into this area. And in this talk, I would like to focus on the third area. So what's actually going on with the transformations and how do we test the transformations in our system? And I'd like to talk about some of these ideas based on one of the projects that I did last year. And yeah, I'll give you a bit of context about this project now. So our goal was to build some pipelines for a client to gain insights so that they could gain insights from the products that they were using, or that the customers actually were using and that they were selling to their customers. So as part of that system, the system was emitting a bunch of wide output tables. And this is an example of what that table could look like. So we partitioned our data by date, and we were outputting some calculated metrics. And these are visible here on the right. So for example, how many daily visits there were to a museum, or how many new membership signups there were at that particular museum. And we were enhancing this data with some reference data. So for example, like in which museum the visit took place, or what was the gender or the age of the visitor, etc. And these denormalized white tables were then accessible by the data analysts, who could build dashboards on top of that, so that business could get some valuable insights and hopefully act on those insights. The architecture that we used in this project wasn't anything particularly exotic. We hosted the system on AWS. The input data was coming into S3 buckets from where we were picking it up. We used AWS step functions for orchestrating our pipelines. And the pipelines themselves consisted of an EMR cluster being spun up, which then triggered a Spark job to actually take the data, process it, and output it. And we outputted the data into another S3 bucket from which we had Redshift pick it up through the use of Redshift Spectrum with Glue Data Catalog for holding the metadata. And on top of the Redshift, we also had a Tableau instance that analysts could use to analyze the data. So pretty straightforward architecture, nothing particularly exotic about it. So into how did we approach testing in this project? And in my mind, I kind of put our testing strategy into 3 different phases. So when we started the project, we were really enthusiastic about testing as much as we could. So we created like 3 layers of testing based on the idea of a testing pyramid. So we had our unit tests, our integration tests, and then our acceptance tests, kind of testing the end-to-end flow of creating those metrics. In the second phase of the testing, we realized that, okay, we're doing a bit too much, and we started to abstract away some of the testing infrastructure that we were using. And finally, the third phase of this testing strategy made us rethink the whole thing because of all of the problems that we saw in the previous phases. And I'll go through all of these phases in more details now. So first of all, as I said, we had a number of data pipelines that consisted of Spark jobs calculating a metric based on some input data. So each metric had its own test suite essentially, and they consisted, like I said, of unit, integration, and acceptance tests. So an example of a unit test could be like this. We picked up some data in the form of data frames, which are essentially just tables with columns and values. So in this case, you can see that we have like an event data frame and the reference data frame on the bottom. And then, yeah, we use the Spark job to apply some transformations on it, and we got an output data frame. And in case of a unit test, we manually created the input data frames, and we also manually created the output data frame, and then we asserted on the output data frame to make sure that it matches the one that the test was producing. In case of integration tests, the setup was quite similar, with the difference that we hosted the data in actual files. So the test was picking up files. We used Spark to read in the files and create the data frames. Then we did the calculations, outputted the data frame, and then wrote it into a file again that was then used for assertions. So the only difference between integration and unit tests essentially was the scope and the I/O operations. And the acceptance tests were pretty similar as well, apart from the difference that then we used the actual real infrastructure and ran all of the pipelines and asserted on kind of the end-to-end result. So yeah, once we've been working with this setup for a bit, we realized that it's not really a perfect setup, and we started noticing some problems with this. So first of all, as I mentioned, each metric essentially had its own test suite. And that test suite consisted of like 5 to 8 unit tests, so a happy path, and then depending on if some of the data sources were missing, what would happen then, and if there were other like edge cases, then we tested them separately as well. On the integration test layer, we were constantly reading input files and writing output files. And on the acceptance test side, the running all of the tests with the real infrastructure was taking quite a lot of time. So to summarize this phase, we realized that with this strategy, the development was quite error prone because we were constantly creating manually our data frames, and this required quite a lot of attention from the engineers so that like, they wouldn't make any silly mistakes. Also, writing these tests required quite a lot of domain knowledge because for each metric that you were creating, you had to know explicitly like how was the data coming in, what was the shape of the actual output data, and for each test that you were creating, you had to pay quite a lot of attention to that, and you had to keep all of this information in your working memory. And the acceptance tests, they were quite brittle because they were using real infrastructure, so we weren't running them quite as often as we wanted to. The second point that we noticed was that the tests were repeating themselves. So like I illustrated already, the unit tests and the integration tests were quite similar, with the exception of handling the I/O operations. And the unit tests were actually quite similar between themselves as well. So each metric essentially had its own test suite, and we were testing basically the same things for each metric, even though the transformations varied only a little bit. And finally, all of these tests took quite a long time to actually run. So in our pipelines, we had the unit and the integration tests, and it sometimes took about an hour to wait for the whole pipeline to finish running so that we could actually merge our branches into the main branch. And this is just wasted time, essentially. And because the acceptance tests took so long, we actually rarely ran them, which meant that there was like an additional maintenance cost that came in because we weren't running them constantly, and there were some bugs that were introduced because of all of that. So what did we do next about it? We realized that some of our issues were due to not using proper abstractions. So we realized that we have quite a lot of code duplication across our system. So we started removing it and introducing some abstractions. So as you can imagine, we introduced some sort of a base metric, which we tested more thoroughly, and then the individual metrics could have less tests in their test suites. And this reduced the number of unit tests and integration tests. The second thing that really worried us was the amount of information that the developers had to keep in their mind so that they could actually write those tests. And we started thinking about using generating synthetic data so that we could keep this domain knowledge inside of the tests. So yeah, looking into generating synthetic data was what we did next. And we started thinking about two approaches. So the first approach that you can probably imagine is the typical unit test approach, and it's called example-based testing. And in that case, you manually specify all of the data that you need inside of the test. So you have some preconditions, you apply your test, and then you do the assertion. But there is also another option, which is called property-based testing, in which case we would have generated like a big amount of synthetic data by just specifying the properties of the data. So for example, for a column customer ID, we would have said that, okay, it's an integer between 1 and 1,000, but we wouldn't have really cared what's the actual value. And we're thinking between these two approaches for generating data. Eventually, we decided to go with the first approach because we wanted to really focus on keeping the domain knowledge of creating a metric inside of the test. So we decided to write a domain-specific language-based solution so that we could use this solution in our integration and unit tests. There are some other tools out there that actually do this, but we took a look at them and most of them didn't really fill our gaps because they were either too generic or too specific, and they were written in languages that weren't really an option at the time for us. So the reason that we liked the idea of creating our own DSL was that we wanted to really focus on making the tests maintainable. So we wanted to be in a situation where the developer doesn't have to go through a lot of files, write all of the test data manually in them, and then make sure that the output files are also correct. We wanted to make sure that all of this knowledge is actually captured inside of the test, so that when you open up a test for a specific metric, you can see like, these are my preconditions, these are the data sources with this kind of data that we need to use, and this is the output data. And we really thought that with this idea of using a DSL, we found our silver bullet. So yeah, this is how our DSL actually looked like. So if you try to remember the table that I showed you at the beginning with like a couple of rows showing visits to a museum and some metrics associated to it, then with this kind of a DSL, we can basically generate the input data and the output data for it. So we have our scenario, we specify who were the people who visited, which museum they visited, and when did the visit actually happen. We used a simple Java builder pattern for it, and this allowed us to really like embrace the example-based testing of specifying all of the test data here, while also keeping the code inside of the test. And with this snippet of DSL, we could have generated data frames for unit tests or actual files for integration tests, and we could have done it in any data format that we need, so be it a CSV, Parquet, Avro, etc. And once we started introducing this approach into our tests, we did notice that the cognitive load, or how much information a developer has to keep in their working memory, we noticed that it actually started decreasing. So the more we started replacing it, the easier it started to become to maintain all of these tests. What we didn't think about at the beginning, though, was that now we'd essentially introduced a parallel system into our code base. So we had our production system, which was all of our pipelines calculating our metrics, but we also had our DSL, which was doing a very similar thing. So creating input files and output files, and of course there were some transformations slipping into the DSL as well. And that kind of starts creating some confusion, like which is the actual reference to the truth. And it didn't really make sense to keep two systems running. And because the DSL was kind of a tool that we used for testing, we didn't put that much design effort into creating that tool as well at the beginning in the back end of the DSL. So the DSL quickly started to become a spaghetti code monster, and that started to become harder and harder to maintain the more metrics we started adding. So eventually, after a certain point, the cognitive load of the team actually started increasing again, because with each additional metric that we created, we had to add it to the production system, and we had to add a bunch of testing infrastructure into the DSL as well to generate the files. So yeah, we weren't quite happy with this situation. And once we had reached that point, we got an opportunity to think through our whole testing strategy again. So we realized that manually creating test data was a big no-no, because it just requires too much effort from the team. But using synthetic data everywhere might not be the best option either. So we learned from this that our integration tests were essentially too heavy. We were constantly doing the same things, like reading data, writing data in the tests, and it really wasn't that necessary. We could have abstracted that part away, tested it once, and then relied on this knowledge everywhere else. And we, as I've mentioned a couple of times already, we finally realized that our integration tests were essentially repeating our unit tests. And with the introduction of the DSL, as I mentioned, the whole test suite had become way too complicated. So how did we rethink our approach? So first, like the action points that we actually took. On the unit test layer, we replaced the DSL with data frames again. So we kind of went back to our previous approach, with the exception that we really focused on what kind of data is necessary for that particular test. So we didn't actually fill the whole data frame with data, but we just focused on the columns that were necessary for that particular transformation. And thus, we really made this tests quite self-contained. On the integration test layer, we got rid of the DSL again, but we replaced it with mocks. So instead of repeating the unit test layer, we started testing that the flow of the information between the components is actually correct. So our integration tests actually started resembling proper integration tests from the software engineering world. And finally, on the acceptance test, we didn't really change that much. We kept the DSL there because there it really made sense to generate some data so that we could test the end-to-end flow of the whole system. And this approach started resembling something that is out there in the industry, and there's this model, Swiss cheese model of testing, that's been created by a thought worker called Corny. And it basically means that instead of focusing exactly on what each layer does, you focus on the whole system, and the whole system is responsible for catching as many bugs as possible. So each layer has its role, but each layer also has its pros and drawbacks. And each layer has some holes through which some bugs might go through, but the following layer might actually catch them. So we really focused on what was the goal of each layer, and we were hoping that by focusing on the system holistically, we're able to minimize the cost of maintaining the test suite, but also keep the effectiveness of the test suite quite high. So that was kind of our way of thinking about it. And yeah, we realized a couple of things with this approach. We realized that yeah, using synthetic data everywhere is not a good idea, but we kind of found the right place for it in the acceptance test layer. And again, it reminded to us how important it really is to use good abstractions so that you could isolate certain functionalities and test them in isolation and not repeat those tests on each layer. And because of all of these changes, the testing pipeline itself became also faster. So the developers were wasting less time waiting around, and yeah, they could focus more on adding value with their work. And yeah, to summarize, what did we actually learn from all of this? I've kind of covered like two extremes of testing transformations in data pipelines. So on one extreme, we had the fact that we are manually constantly creating test data, which wasn't the best idea at the time for the team because it was increasing our cognitive load too much. But we also had the other extreme of using synthetic data everywhere, which is also not the best idea because of the maintenance cost of the DSL and the system of creating the data. So we learned that you have to use synthetic data quite sparingly and make sure that there is an actual reason for using it. So for us, it kind of made sense to use it on the end-to-end flow of the system, but not on the actual bottom layers of the testing suite. And with this approach of kind of going in the middle, or sometimes you creating test data manually, and in some cases creating test data synthetically, and really focusing on what each layer of our testing suite actually had to accomplish, we kind of reached a holistic view of testing our system, which gave us like the maximum amount of confidence we could in our system, while also minimizing the cost of maintenance. So yeah, this is my talk, and if you have any questions, let me know. I'm happy to answer anything.
Thank you, Arne, for the great talk. We will now wait for the questions a little bit. No questions so far. Maybe your talk was so clear that there are no questions.
Well, everyone's free to reach out to me later privately as well.
So anything interesting to share about the climbing? Because I saw that you are a passionate climber.
Oh, it's absolutely amazing. I'm totally obsessed with it.
Okay, we have one question. What was the biggest mistake you made? Which cost was the highest? Victoria is asking.
Thank you, Victoria, for this question. And I think the biggest mistake was thinking that generating synthetic data and using it across all of our testing layers was the silver bullet to our issues with testing at the start. So we became really enthusiastic about our DSL, and we started immediately using it across all of the testing layers. So there was like, a cost of replacing our existing tests with the tests using the synthetic data. So that was kind of a wasted effort in the end because like we rolled back all of it. And yeah, thinking that one particular technique or a tool is the answer to all of the problems instead of thinking about the system as a whole holistically and like thinking through what each layer of testing actually has to accomplish. I hope that answered your question.
Thank you for the answer. Let's wait a little bit more for more questions. Come on, guys, don't be shy. You can ask whatever you want. Victoria is again asking why Spark, not Snowflake.
The answer is actually quite easy. That particular client was pretty adamant about which technologies to use, and Snowflake wasn't even an option, to be honest. The architecture that we had was pretty much set by the constraints of that particular organization. So doing anything too exotic was really out of the question.
And if you, to extend a little bit the question, if you were to decide which one would you choose between Spark and Snowflake?
Well, I mean, it doesn't have to be one or the other. It really depends on the actual use case. So in our case, our architecture, again, it was due to the client constraints and spending so much effort in actually creating Spark jobs to take raw data and apply transformations to it. Like in hindsight, it wasn't actually the best strategy for that particular client. So taking all of that data, putting it into a data lake, and then either putting a Snowflake on top of that or a query engine or anything like that would have probably been an easier way of fast tracking them to getting some value out of that data.
But it would be harder to do with that client.
Yeah, exactly.
Okay. Any other questions? So what future projects, something interesting coming up for you?
Yes, I've just started a project in the domain of data catalogs and data discovery. That's a really cool area when we think about the principles of data mesh, which ThoughtWorks also promotes quite heavily since they come from us. So yeah, data discovery, that's very interesting.
Okay. Okay, I guess there are no more questions for you, Arne.
Thank you for listening.
And we are going to wrap it up. Thank you very much for the talk. It was very informative, very useful, very interesting to find out. And hope to have you again here with us. Thank you. Bye bye.